Here we're going to identify linear equations. And to do that, we need to look at the x and the y. As long as the x and the y are not have any exponents or multiplied by another variable, we have a linear equation. And one way to be able to tell this is if we write a linear equation in standard form. So standard form is the x and the y on one side of the equal sign equaling a constant or a number. So right now I have y on one side of the equal sign and I have the negative 3x on the right side. So I want to move the negative 3x to the side. So anytime we move or change sides with equal sign, it changes signs. So this negative 3x becomes a 3x. We still have the plus y, and now it equals 4. So this is what's called standard form, and because we have just one x and just one y, you don't have to have them both, you just have to have one. We have a linear equation. Now let's look at this problem. Same thing, we have just one y, but we have no x. There's no multiplication of the variables, so this is also linear, but it's not in standard form. As we've done in the past, we want to get rid of the fraction by multiplying by what's on the bottom of the denominator. So if I take my 1/3 and multiply everything by that 3, on the left side it cancels, which leaves me with 1y, or just y. And on the other side I get a negative 3. Because y is not multiplied with any other variable, it's also linear, but now this is standard form because the variables are on the left and the constant is on the right. If we want to graph linear equations when it's in standard form, we can use what's called the x and y intercepts. Now, x-intercept is related by making y equals 0. The y-intercept is by making x equals 0. Notice that x and y are always together. So if I'm finding the x-intercept, I'm going to use the y to find it. If I'm trying to find the y-intercept, I'm going to use the x to find it. So let's go through this process. We're going to find the x-intercept. So I'm going to make y 0. So in this equation, I have 2x plus, and I'm going to put 0 for y equals 16. Well, 0 times 4 is 0. So now I just have 2x. So basically, we eliminate the y-coordinate. And then if I solve this, I get what x equals. And what x equals is the intercept. Now, the coordinate of that is 8 and y is 0. So let's look over here at this problem. We want to find the y-intercept. So to find the y-intercept, I'm going to make x 0 in the same equation. So now it's 2 times 0 plus 4y equals 16. Once again, the x disappears because that's 0, so we're left with 4y equals 16. So you're eliminating one of the variables when you're trying to find the intercepts. Divide by 4, divide by 4. So I get my y-intercept is 4, or in this case, 0, 4 is the coordinate. Now let's look at this particular problem. So I have a negative x plus 2y equals 3. So I want to find the y-intercept. So I'm going to make x equals 0. So this disappears, so I just have 2y equals 3, divide by 2, y equals 3 halves. So there's my y-intercept, and the coordinate of that is 0, 3 halves. 3 halves. Now let's find the x-intercept. So I'm going to make y equals 0. So in this becomes 0, and I have a negative x equals 3. That's a negative 1. If I divide by negative 1, I get x equals negative 3. So my coordinate is negative 3, 0. So there's my x and y intercepts for this equation. All right, this last equation, y equals a negative x minus 5. The problem with this equation is not in standard form like the other two. So I'm going to move the negative x over, so it becomes x plus y equals a negative 5. And now I can find my y-intercept by making x equals 0. So if I make this 0, y equals a negative 5. And then I can find my x-intercept by making y 0. So this becomes 0, so x equals a negative 5. Now, if we look at this, and I want to write the coordinates, this is a 0, negative 5, that's the coordinates. and this is a negative 5, 0. They're not the same coordinate. So let's prove this on a graph. So if on a graph I have negative 0, negative 5, 1, 2, 3, 4, 5, I have that point right here, and negative 5, 0 is 1, 2, 3, 4, 5 right here, and so I can connect those two dots by using these intercepts. And so once you have the intercepts, it's pretty easy to graph if you know the coordinates from the intercepts. Another way of graphing is by making a table, and this is when it's not in standard form, and this is not in standard form, we can use by substituting x values. So we can take x values and pick any of them. Usually you have to pick a negative number, 0, a positive number. And when you pick those numbers, you substitute that in, as they've done here, you'll get the y value. So if x is a negative 3, we get 1. And when we put 0 in, we get 2. And the work's right here. And if I put a 3 in, a positive 3, I get 3. Now, you can do another number if you want to, but this is good enough because 3 points make a line. Then if you go over to the graph, which we have right here, we go to negative 3, 1, which is there, 0, 2, right there, and 3, 3 right there, and you connect them, you have the graph. So you can graph by picking out values, and these are any numbers you want. I usually like to pick numbers that are small or numbers that get rid of fractions. The reason why we pick negative 3 is because we have a 1/3.